Bright Tuty. Every student matters.
Hello dear students, my name is Amit Ajmani and we'll be continuing work and energy. Clear? Now, till now we have studied about kinetic energy in the previous topic, in which we have seen that kinetic energy is basically the energy of a body due to its motion or speed. And we have seen the impact formula and numericals of kinetic energy. Today we'll be studying about a different form of energy, and for that, first of all, we'll be performing a few activities. Let us see. In the first activity, what will we do is we'll take a rubber band, just hold it at one end and pull from the other. What we do is we see that the band stretches. Now release the band at one of the ends. What happens? The band will tend to regain its original length. Now this is quite obvious that the band must have acquired some energy in its stretched position, right? Now from where that energy being acquired by the band? So there must be some form of energy which is acquired by the band when it has changed its shape, when it was stretched, right? Okay, what is that energy? We'll discuss after doing another activity. The way we have taken a band, now we'll take a slinky, right? This is a kind of spring or a slinky, if you must have seen. Now ask one of your friend to hold one of its end and you hold the other end and move away from your friend. Now once again, the way we have just left and release the band, we will release the slinky from one of the ends. Now once again, what happened is we see that there is a change in shape and again the slinky will regain its original shape. Once again the same concept happened, that there must have been some energy which has been acquired by the slinky, because of which it regained its original length, right? Next activity, we must have seen some toy cars just being dragged or moved with a winding key. So the same we are going to do, we will wind the key of the toy car and then place the car on the ground. Did it move? Of course yes. Now why did it move? There must be some kind of energy which was there and which actually was acquired by the toy car, because we just wound it up, right? What is that form of energy? Let's see. Next, lift an object through a certain height. Now the object can do some work. It begins to fall when it is released. This also implies that it has acquired some energy, and the greater height we have just made the object to go, the more work it will be able to do. Hence it means that it possessed more energy. Now where did it get the energy? All these examples that we have taken, all these examples that we have seen and observed, we have discussed. In all these examples we have seen that an object, when raised to some height or whenever there is some change in shape of the object, it acquires some energy. Now is the time to tell you what exactly is that energy called. That energy is known as potential energy. Now, what exactly is potential energy? When we define it, we say that it is the form of energy which is possessed, contained in a body due to its change in shape or position above the ground level. So there are two things which cause this potential energy. One is the change in shape of the object, right, as we have seen in the case of rubber band, in the case of slinky, right? Wherever there is a change in shape, this potential energy is acquired by that particular object. And second thing is because of the position above the ground level. Now when I am talking about the ground level, I am not just saying the earth's level. Maybe I have kept some particular object like a pen on a book, and that book is kept at some height, right? Just look at me for 1 second. Now I am placing, supposedly this is my hand or a book, I am placing a pen over here. Now when this pen is placed on that particular hand or book, so book or the hand is its ground level. Fine. So now if I raise this particular pen to certain level, then I will say that it is the position above the ground level. Got it? So then it will have some potential energy, but if it is kept on the hand, then because its ground level is the hand and its height is 0, therefore I can't say that this is having potential energy, right? But yeah, when I carry this pen and at the same height I take it over here, now exactly its ground level changes. Now its ground level is the actual ground, the surface of the earth. So now once again it has got some height, once again we can say that it has got some potential energy, right? So these are the two things because of which an object has potential energy. Clear to all? Now based on these two things, we say that potential energy is of two types. First type we say is elastic potential energy. Now what is elastic potential energy? It is the energy which is in a body due to its change in shape. Elastic potential energy is the energy because of change in shape. All the objects which have some energy because of changing their shape, for example the stretched rubber band, the stretched slinky, or the toy car, in which actually when we are winding the key we are actually changing the shape of a spring which is inside. So that energy possessed because of that change in shape is known as elastic potential energy. And the another one is known as gravitational potential energy. Now what is gravitational potential energy? It is the type of potential energy which is basically contained or possessed by a body because of its position above the ground level or its height, right? So ultimately what we see over here is whenever we are changing the shape or we are carrying the object to a certain height, actually for both the things we are performing some work, and that work that is performed by us has been stored in these objects in the form of potential energy. Got it? So these are the two types of potential energy. Fine. Now in order to see what exactly mathematically potential energy is, it's very simple. We'll just assume that this is the ground level. We'll take a stone of mass m and we will raise it to a height. Let us say this height is h. Clear? Now to carry this stone of mass m to such a height, we need to apply some force on it. And the force, as per Newton's second law of motion, we see that force is the product of mass and acceleration. And since the acceleration in this case is because of acceleration due to gravity, so we will say that F is equal to m into g. Let it be our first equation. Got it? Now in order to carry this stone to this height by applying this force, we see that we have done some work. And what exactly will be the work done? We know that work done is calculated by the formula F into S, where F is the force and S is the distance moved by the object. From equation 1, we can relate that F is equal to m into g. So I can just relate and I can just put the value of F to be m into g. I can replace it. Multiply by, now the distance which is moved by this object is expressed in terms of its height, which we have taken to be h. So we say that the work done is equal to mgh, right? Now this is the work that we are doing against gravity, because we are carrying this object to a certain height, right? Now whatever work is being done, it is done because we have seen that whenever a body has to do some work, it needs to have energy. Without energy we can't do any work. So this work done is equivalent to energy, and this energy is because we are carrying the object to a certain height, it is gravitational potential energy. So we can say that potential energy is equal to mgh. So this is the mathematical expression of potential energy, where in this formula if we see Pe is a potential energy. This potential energy we can also represent it by energy, and we can write P here, right, as an underscript. So EP or Pe is equal to potential energy, m is the mass of the object, g is the acceleration due to gravity, as we know, and h is the height of the object. Got it? Now mass, we know that the SI unit is kilogram, height we know that the SI unit is meter, and acceleration due to gravity we know that we take its value to be 9.8 meter per second square, right? And potential energy, since it is a form of energy, so its SI unit will be same as that of energy, which is joule, represented by capital J. So this is the mathematical expression for potential energy. Now if we try to relate the formula, we see that the value of G we take to be is taken to be 9.8 meter per second square. I repeat, the value of G is constant and is taken to be 9.8 meter per second square, even though in gravitation we have studied that on the surface of earth also the value of G is slightly different, but for doing numericals or otherwise also we take it to be constant 9.8 meter per second square. So if we remove this constant value of G, we see that there are two things left in the formula, mass and height. Therefore, we say that the factors on which potential energy of a body depends are, now there are two factors. The first factor is the mass of the object. And how is potential energy dependent on it? Potential energy is directly proportional to the mass. That means if the mass is increasing, that means the potential energy will be directly impacted and it will also increase. Got it? And the second factor on which the potential energy depends is height of the object. Height, what we mean to say by saying height, it is the distance above the or position above the ground level. And potential energy is directly proportional once again to the height of the body. The more will be the height, the more will be the amount of potential energy that particular object will be having, and the more potential energy means the more work will be done by the object. Got it? Fine. So this is about potential energy. Now one thing quite importantly we need to relate is that through an activity we will see what? We'll take a bamboo stick and make a bow out of it as shown in the figure. Then we'll place an arrow, and while we stretch this, now by stretching this string we know that we have changed the shape, and this will be once again a type of potential energy, that is elastic potential energy. Now when we release this arrow, we see that this arrow moves in the forward direction, right? Why is it so? Because in just stretching the string we applied some work. that work was stored in this particular string in the form of potential energy, and the moment we released it, that potential energy that was stored in the bow due to the change of the shape is converted into kinetic energy by throwing of the arrow, right? So whenever we are making an object to acquire some potential energy, because of that it can do some work, it is converted to some other form of energy. Like in this case, we saw that the potential energy was converted into kinetic energy. Clear? Now we have said that potential energy is directly proportional to height. Now when I talk about the height, I am talking about the initial position and the final positions difference. The difference between the two positions is termed as height, right? Okay. So if an object is taken to a height of, let us say, 10 meters, right, it doesn't make any difference that if we allow this particular object to fall from a height of 10 meters, the potential energy will calculate by taking the value of h regardless of the path it takes. Now what I mean by saying it is, try to relate with the help of this figure. One option was that this object was falling straight, right? Then in that case height was 10 meters. In the other case, the path taken by this is a bit curved, but again the difference between the two positions remains the same, that is height, that is 10 meters in this case. So the stone which is dropped in this particular way or in this particular way, both ways it has acquired the same potential energy because of the same height, regardless of how exactly this particular block or this particular object, which particular path it has taken, it is not dependent on that. Clear? So this is important that we need to remember. So what does it mean? That if I am pulling some object through a rope in a vertical direction, or I take it in a different path, or I can just take that particular object on me, or we take it upwards using the staircase, we carry it using the staircase, the potential energy in the object will remain the same. Got it? Fine. Let us see the concept of potential energy through this quite interesting animated video. I hope you will like it and you will relate it and understand it properly and thoroughly through this. So we'll try to relate the mathematical expression for potential energy and the concept of height. First of all, we'll consider a stone of mass m. Initially, it was at ground level, raised vertically upward through height h against the gravity such that the acceleration is small g, right? So, the height is h, the mass is m, acceleration due to gravity is g. Considering the force acting on the stone, of course, it will be m into g. Therefore, the total work done in lifting the stone will be equal to force into distance. The force is m into g and the distance is small h. But the total amount of work done in lifting the stone is equal to the energy spent. Therefore, the energy spent in lifting the stone will be equivalent to mgh. And as the energy spent in lifting the stone is stored within the stone in the form of potential energy, therefore, we can relate that potential energy will be equal to energy spent in lifting the stone. Therefore, potential energy or PE is equal to mgh. Now, very importantly, it is useful to note that potential energy or the work done against gravity depends upon height between the initial and final position and not the path along which an object is raised. For example, we can raise a bag of 20 kg to the top floor of building 10 meter high by pulling it vertically upward with a rope in a straight line, or by taking it upward through a staircase. In either of the cases, the potential energy in bag will be same as it is raised through same height. Got it? This is what I had told you. I hope you must have understood it through this very interesting animated video, right? So now you have understood the concept of potential energy and the formula is mgh. Now put that formula into some use. Let us put that formula now into use and let us do a few questions. Let us see how the questions will be getting in our exam.